Today we're going to start talking about a new construct called loops, which is going to allow us to repetitively uh, compute or do a computation. So thus far we've only been able to do a computation once. For example, if I want to do the miles per gallon calculation, I can prompt the user for some inputs, calculate miles per gallon, and then exit. But let's say I want to allow the user to do that calculation several times. Maybe they have several different cars they're considering and they want to calculate the miles per gallon for each car. Then they'd like to be able to do the computation more than once. And loops will allow us to do that. Before we get to loops, there's two common C++ pitfalls that I just wanted to quickly go over. The first is how to calculate a exponent like I squared. Some of you have some experience with MATLAB and you're going to be prone to write an exponent like that with the little caret. That's not the right way to do it in C++. It will get you a compiler error. The correct way to do it in C++ is simply to do the multiplication of I by itself. And you might say, well, what if I had I cubed? You just have to say I times I times I. C++ does not have a built-in syntax for handling exponents. We'll find out when we get to functions that it does have a library that you could import and it has a power function, but that's beyond the scope of where we are right now. So right now just multiply your numbers together to get your exponents. The second problem is that a lot of you are wanting to write your conditional statements like this. If you want to check if a variable is one of several values, it seems natural to write it like if gender is equal to capital F or small f. But in fact, this will always get you a true result. And the reason is that this is not comparing the small f with gender. It's just an f. And remember, any non-zero value is true. So what this is really doing is it's actually first evaluating to see if gender is equal to a capital F. Let's say that's false. Let's say it was really a small f. Let's actually say it was a capital M for male. Okay, so this would fail. Next, it just evaluates the f by itself. It doesn't ask if gender is equal to f. It just says f, and that's true. It's not zero. So if you really want to check to see whether gender is equal to a capital F or a lowercase f, you have to write it out like that. Also, don't forget you need to have the single quote. Some of you want to write it like this, and C++ doesn't understand that you mean for gender to be compared with a character. It thinks you want to compare gender with the variable named capital F and the variable named F, and that's no good. So remember to have your single quotes. The agenda for today is to talk about loops, and there's three types of loops. There's while loops, do while loops, and for loops. We're not going to talk about for loops today. And then we're going to terminate today by talking about nested loops, where we embed one loop within a second loop. So again, my motivation is, let's say I want to allow the user to repeat the miles per gallon calculation as many times as they want. I would have to add something to my program to make that happen, and that's going to be a loop. So here's our original miles per gallon program, just to refresh your memory. So you prompted the user for the number of miles driven and gallons consumed. Then you read it in. Next, you divided gallons consumed into miles driven and assigned the result to miles per gallon. Finally, you printed it out. So, in order to allow repetition, we're going to introduce this construct called a while loop. And The while loop starts with a conditional test that determines whether we want to repeat the loop. So in this case, we're going to repeat it as long as miles driven is not equal to 0. And up here in our cout statement, we modified it. You'll notice here we said enter 00 to quit, so that if the user enters 0 for miles driven, then we will end the loop and not repeat it. So let's say we enter 25 for miles driven, so that would make this condition true. I'm sorry, it would make it false because miles driven would not be equal to 0. So as long as, it makes the statement true. This is why, by the way, not is often a difficult operator to deal with. It's not intuitive. So what we're saying is while 25 is not equal to 0, and that is true. So while this condition is true, we're going to go into our loop. So we calculate miles per gallon and we print it out. And now we want to query the user again to see whether they want to do another calculation or whether they want to quit. And then we have to read these values in so that when we go back to the top of the loop right here and evaluate the condition, we're doing it with the new values that the user input. And we will keep executing this loop body until the condition becomes false. And notice that the loop body is delimited with curly braces. That's how C++ knows where the loop body begins and ends. And as I just said, loops give us a very powerful capability, which is the ability to execute the same block of code or the same computation multiple times. And they also give us the ability to determine when we would like to terminate that computation. It may help you to view a while loop using a flowchart. So here it is. We have the expression, and that has to evaluate to true or false, so it's a Boolean expression. If that statement is true, then we go down and we execute the statements in the loop body, and when we're done, we come back up and evaluate the Boolean expression again. Ultimately, that expression becomes false, and we come down and pick up with the statements that are after the while. So again, the statements in a loop, which are these statements right here, are called the loop body. Each repetition of the loop body is called an iteration of the loop. So each time, one time through and back gives us one iteration, and the loop body is repeatedly executed until this Boolean expression right here becomes false. That's the three big elements of the loop. And you might ask, when does the computer evaluate the Boolean expression? It's before we execute the loop body. So we often call this pre-testing because we do the test before evaluating the loop body. It's like a guard, and we can't get past the guard unless, quote, the password is true, right? We give the guard some challenge, or the guard challenges us, and we have to give them some piece of information that the guard likes before it lets us through. In this case, it's a Boolean expression. It has to evaluate to true. And an important point is that it's possible that the loop body is not executed at all. If the user in that miles per gallon computation had immediately entered a 0 for miles driven, the loop body would never have executed. And in this case, you might think, well, why did the user run the program? And that'd be a legitimate point. But there are computations where it is possible that there is no where the loop doesn't have to execute. For example, let's say that we had entered values and now we want it to keep prompting the user to enter a positive value for miles driven if they'd entered a negative value. So we might have a loop that's going to want to say while miles driven is less than or equal to 0, prompts the user, the loop body prompts the user for a positive miles driven and reads it in, and it keeps doing it until the user gives us a positive miles driven. Well, if the user started by giving us a positive miles driven, we'd never want to execute the loop. So there's an example where we don't need to have the loop execute ever. Let's look at another example now of a while loop. So we're going to ask the user how many times they want to see the message hello world, and we'll print it that many times. So here's the code over here, and I've declared a variable called how many greetings, and it's going to store how many times we want to print hello world. So then I print a prompt asking the user how many greetings they want, and I read it in. And now my loop is going to print out hello Brad, and it's going to do it however many times I've told it to. So let's say I entered 5 for how many greetings, it's going to do it 5 times. Well, how do I arrange for that to happen? I'll start by saying a condition, how many greetings greater than 0. So as long as that variable is greater than 0, I will continue. And I'll print out hello Brad, and then I'll decrement the remaining number of greetings I have to print. So if I start it with 5 greetings, you can see that each time through the number of remaining greetings will be decremented by 1. So it would first be 5, then 4, then 3, 2, 1, and eventually it'd be 0, and the loop would terminate. And over here, I've got a pictorial representation as a flowchart of the loop. So we have the statements before that actually print out how many greetings do you want. And this was unfortunate because it had to be another one here, cin how many greetings. And this is called a priming read because it is setting up the value of how many greetings so that it is actually it's been initialized before I go into the loop. So now I come down after reading how many greetings, and as long as it's greater than 0, I come down the true branch and I execute the loop body, taking care to always decrement how many greetings, and then after I'm done with executing the loop body, I come up again to this expression, evaluate it. Eventually it becomes false and I exit. Notice it's important right here that I remembered to decrement how many greetings by 1 each time. If I forgot, I would get into what's called an infinite loop. The loop would never terminate. It would just keep printing out hello Brad an infinite number of times or until you got bored and did something to terminate the program. So it's important when we use a while loop to do something inside the loop body that is going to potentially make our Boolean expression evaluate to false. If we don't, we'll get an infinite loop. So here's an exercise that I'm going to work through. So we've got this loop here, and the question is, what is going to be the output of this loop? Well, initially x is set to the value 10. So over here I'm going to place 10 into x. Now we start into the loop and we'll say while x is greater than 0. Well, x is 10, that's greater than 0, so we output the value of x, which is 10. And now we make some progress toward exiting the loop. We subtract 3 from x, which gives us 7, and we assign that value back into x. So x is now 7. We come back to the top of the loop. 7 is greater than 0, so again, we output this value of x. And notice that there was an end line here, so the next value gets output on a new line. So 7 gets output on its own line. And again, we execute x equal x minus 3. So 7 minus 3 is 4. So x now has the value of 4. Okay, x is still greater than 0. So we execute the cout, and we output 4. Now we execute the statement x equal x minus 3. So 4 minus 3 is 1. We assign 1 to x. X is still greater than 0. We again execute this output statement and output 1, the value of x. Evaluate x again and subtract 3 from it. So 1 minus 3 is minus 2. Now when we evaluate the Boolean expression, minus 2 is not greater than 0, so the condition is false, and we exit the loop. So our output is 10, 7, 4, and 1. So just like we have while loops, the second type of loop is a do-while loop. So here's an example for motivating a do-while loop. We want to prompt the user for gallons consumed. We want to check to ensure that the entered amount is a positive integer. And if it's not a positive integer, then we want to keep asking the user for gallons consumed until the user enters a positive integer. So here's a sample interaction down here. The first 2 times the user ignores this and does not enter a positive integer, but we're persistent, and eventually the user enters 8 and will be happy. Now, a do-while loop has the characteristic that we always want to repeat the loop at least 1 time. Remember that a while loop might execute 0 times. With a do-while loop, we want it to execute at least once, and we put our Boolean expression that determines whether the loop executes again at the bottom of the loop. It becomes what's called a post test. So here, the loop body, we ask the user to enter a positive integer, and we then read the value into gallons consumed. And by the time we get here, gallons consumed is initialized, so we didn't need a priming read this time before the loop body because the loop body itself initialized gallons consumed. And we're going to repeat doing the loop while gallons consumed is less than 0. Again, it may be easier if you view this as a flowchart. So with a do-while loop, the loop body gets executed once before we even check the Boolean expression. And then if that Boolean expression is true, we'll do the loop body again. If it's false, then we'll execute the statements after the do-while. And again, because the Boolean expression follows the loop, then we say that this is an example of post-testing. And notice again that the statements are enclosed in curly braces, so that's what tells the dilemmas that tell the C++ compiler where the statements begin and end. Now this form of the while is rarely used, and the reason it's rarely used is oftentimes we want to allow for the possibility that the loop body should never be executed, and therefore we want the guard to appear at the top. That is, we want to do pre-testing. But let's work through an example with a do-while. So here we set the value of x to be minus 42, so I'll enter that right here. And then we execute the statement at least once. So we output x, and x is minus 42. Now we subtract 3 from x, coming up with minus 45. So now we assign minus 45. Say while x is greater than 0. Well, x is not greater than 0, right? That's minus 45, so we exit the loop. But notice that despite the fact that x was less than 0 to begin with, we still executed the loop once and printed minus 42. I also want to just quickly show you that if I reversed this condition and had said while x is less than 0, I would also have gotten into an infinite loop. Before, the infinite loop was caused by the fact that I never updated how many greetings. In this case, I am updating x, but the problem is I'm always making x get smaller, more negative, and it would never increase toward a positive number. So you can also get an infinite loop by misstating your initial Boolean expression. Here we really need it to say while it was greater than 0. The final topic we're going to talk about today is nested loops. Sometimes I want to be able to embed one loop within another, and the example we've been working with today is a great example. So I may want to allow the user to repeat the miles per gallon calculation as many times as they want, so that's this condition. But I also, each time they do the miles per gallon calculation, I want to make sure that they enter a positive value for miles per gallon and gallons consumed. And if they don't, then I want to keep prompting them to do so until they give me a positive one. So I essentially want to use that while loop to allow the user to repeat the MPG calculation, and I want to use the do while loop to prompt the user to enter non-negative values. So I can do that by using nested loops. So I'm going to place the do while statement inside the while loop, inside the while loop that does the MPG, and we call this a nested loop. The do while is a nested loop. You'll also hear us refer to it as an inner loop. So here's my code fragment for doing it. Initially, I would have to have some code to read the miles driven and gallons consumed. And then I'm going to keep repeating my calculation until miles driven is not equal to 0. So if it's not equal to 0, I'm going to assume it's positive and that gallons consumed is also positive and do my calculation. Then I print out miles per gallon. Now I'm going to set up for my next calculation, and I'm going to do that using this nested do loop. Again, it's sometimes called an inner loop. And I ask the user to enter either a positive integer or 0, 0 to quit. And then I read the miles driven and gallons consumed. And I'm going to do it until I want to make sure that both miles driven and gallons consumed are positive integers. So I'm going to keep doing this prompting until they are both positive, meaning if either miles driven is less than 0 or gallons consumed is less than 0, I'm going to want to repeat this do while loop. And hopefully some of the more discerning among you might notice that this isn't perfect code, because they could enter a positive value for miles driven like 25 and 0 for gallons consumed, and it would actually execute this outer loop one more time. Miles driven would be 25 and we divide by 0. So if I was really being careful, I would say enter 0 and something else, not necessarily 0, 0 to quit. And I would make sure that I kept going while miles driven was less than 0, because I could exit if miles driven was equal to 0, but I'd want to make sure gallons consumed was always greater than 0. So really I should have added a test here to make sure that gallons consumed was had to be actually positive.